Good morning everyone. Today we are presenting our project titled PREVAIL, which is a predictive IoT-based land fire risk monitoring system. Land fires are becoming increasingly serious environmental and public safety issues across the world. Rapid urbanization and continuous increase in the municipal solid waste have created large unmanaged waste accumulation zones. Over time, decomposition inside these landfills produce methane gas and internal heat buildup, creating a condition that can lead to spontaneous combustion. The problem with the most existing fire monitoring system is that they are reactive rather than predictive. In most cases, actions begin only after smokes or fumes become visible. But by that time, the fire has already seen containment extremely difficult. One of the major inspirations for our project was Brahmapuram fire incident, which took place in 2023 in Kerala. According to our studies, methane accumulation and rising internal temperature, dry plastic layer, and lack of predictive monitoring system significantly contributed to this disaster. The fire spread across massive areas and continued for nearly 2 weeks, releasing toxic gases and the air quality severely in our metropolitan cities. What stood out most was that there was no clear early warning system or pre-ignition sensors deployed at this site. Detection happened only after when visible smokes appeared. This made us ask an important question. What if landfills could be predicted before ignition actually occurs? This question became the foundation to our idea of PREVAIL. Our goal is to create a low-cost, scalable, intelligent monitoring system capable of continuously observing landfill conditions and generating alerts before hazardous situations turn into active fires.
To address this issue, we designed an IoT-based predictive monitoring system built around ESP32 microcontroller platform. The core idea behind PREVAIL is not just fire detection, but fire risk prediction. Instead of relying on a single sensor, our system combines data from multiple environmental sensors to identify dangerous patterns developing inside landfill regions. This approach is called multi-sensor data fusion. The system continuously monitors temperature, gas concentration, atmospheric pressure, landfill movement or instability, and early smoke or infrared signals. Each of these parameters acts as indicator of possible fire development. For example, rising temperature may indicate internal microbial heating, methane buildup may indicate trapped landfill gas, pressure spikes may suggest gas pocket formation, and smoke detection may indicate early smoldering. All sensor readings are collected by the ESP32 controller, where the system processes the information and evaluates the fire risk level in real time. If abnormal conditions are detected, the system immediately displays alerts locally using an LED display, activates warning indicators, and sends remote notifications through Wi-Fi communication. What makes this system powerful is that it focuses on identifying the warning signs hours or even days before a major fire begins. This transforms landfill safety from a reactive emergency response system into a proactive prevention system.
Now let's look into the technical side of our system. The entire system is built around a MYOSA ESP32 microcontroller. We have chosen it because of its built-in Wi-Fi compatibility, its compatibility with IoT applications, its low power consumption, reliability, etc. Our system integrates multiple sensors and uses a multi-sensor fusion approach. We have uses each sensor for monitoring each specific environment conditions. First, let's discuss. Let's see the humidity sensor, which we have placed at the bottom layer. Our humidity and temperature sensor is mainly DHT222, which is used to monitor internal temperatures, heat buildup, gas accumulation temperatures, which we have inserted inside the gas layer and the waste layers you can see now. Next is our gas sensors. Gas sensors are namely MQ2 and MQ135, which we have placed at bottom side and the top side. It is used for mainly monitoring our internal gases. mainly methane. Methane is one of the most dangerous gases due to which landfill fire occurs. Our main approach to our program is that we use these gas sensors to monitor internal gases. Next is our motion sensor, which I have placed at the bottom side, right side of the MQ sensor. MPU6050 sensor is the sensor we have used for the motion detection. It detects the internal landfill tilting, landfill movement, structural inabilities. It detects all of these. Next is our pressure sensor, which we have placed at the bottom layer below our temperature and humidity sensor. It is used to measure the gas or atmospheric temperature variations, pressure variations. It helps us to monitor our internal gas pressure, which helps in detecting the chemical reactions built inside the waste layers. All the sensor data we have gathered from the sensor is fed to the MYOSA board, which we have placed at the side control panel.
The importance of PREVAIL lies in the time advantage it provides. Even a few hours of early warning can help authorities release trapped methane, cool rising hotspots, evacuate workers, and deploy preventive firefighting measures before ignition spreads. According to this project analysis, predictive interventions could potentially reduce environmental damage and emergency response costs dramatically. This system also offers several practical advantages: low-cost implementation, real-time monitoring, remote accessibility through IoT, scalable deployment, reduced human risk, early hazard prediction, better environmental safety. This project is also highly adaptable. In the future, this system can be expanded using AI-based predictive analytics, cloud dashboards, GPS-based hotspot mapping, drone-assisted monitoring, and even solar-powered autonomous sensor nodes. The report also highlights that ESP32-based sensor nodes can operate on battery or solar power in remote landfill regions, making large-scale deployment practical and sustainable. Most importantly, PREVAIL represents a shift in approach. Instead of waiting for a disaster and reacting to it, we focus on identifying risk conditions early enough to prevent the disaster entirely. To conclude, PREVAIL is a smart, scalable, and predictive IoT-based landfill fire monitoring system that combines sensors, sensor fusions, real-time analysis, and wireless alerting to create a safer and more proactive waste managing environment.
PREVAIL is not just a fire detection system. It's an early warning intelligence system designed to protect people, infrastructure, and the environment before disaster begins. Thank you.